Hello everyone, Jonathan here. In this video I'm going to be going over what you can do with Virtuoso directly in the host environment. And what we're talking about there is the ability to design a host environment at this high level, which is very quick and very easy, but then also be able to extend that design directly inside the native host environment. And so what we say in the low-code terminology is that this is the fourth and fifth generation language of application design, and this is the third generation language. So you have your C# and Javas and C++, those are third generation languages. And what Virtuoso is providing fourth and fifth generation language on top of that. And so if I drag and drop LED and a push button, you could say that this design is fourth generation language because I'm designing things at a high level. It is a design. It's fairly complex. It's doing a lot of actual design work. And then the fifth generation language part would be just taking the properties of a component and configuring them. So if it's really just configuring application, that's like the highest level of configuration of the design. So what this platform gives you is from the fifth generation all the way down to the third generation, letting you build your host and never having any kind of restrictions. Because you'll have a lot of great components, but for a particular project that you're working on, there's a pretty good chance that you're going to want to customize it somehow. So what this video is about is explaining how the host environment works and how you can easily directly design inside that. So we just dragged and dropped a push button and an LED. And when I look at the changes to the C# project, the C# project is a Windows Presentation Foundation project. So if you're not familiar with that, it's a type of project that's built on the model view model design pattern. And so this project has a view, which is main window.xaml, and then there's a host view model. And so the idea here is that these design patterns keep the view and the business logic separated so that it helps to design them independently. You can focus on what the application is supposed to do, or you can focus on how it's supposed to look, and then you can work faster. So this view, you've seen us open and you've seen our LED and our push button. And so using this visual environment, we can just drag and drop the controls, move them around, resize them. And this is called XAML code, XAML. So when you drag and drop a component in Virtuoso that has a corresponding visual element, that single node is emitting code for that corresponding element in the view. And it's also adding code in the view model to provide the object in the view model that needs to do the business logic. So you can think of every 4GL component in Virtuoso as adding the visual component and the view model. So if I open up this host view model, we have the host view model itself, and then you can see there's the basic initialize and connect methods. And the host view model implements base host view model. So base host view model is what Virtuoso emits and is responsible for driving. So when you drag and drop components that have view models, Virtuoso is going to be overriding this file, so you wouldn't ever want to change this file. But host view model, which inherits from that, you're completely free to add whatever code you want to add to the project. So base host view model is inside Virtuoso core here. So if we open that up, we can see we have our LED view model, LED1, and our momentary push button view model, memory button 1. So really, if you're wanting to design a new component in Virtuoso, you just design your view model class, design your view class, and then there's a wizard to tell Virtuoso what code needs to be emitted where to add these components to the project. So we have basically the property itself with its backing field, and then there's going to be a stage where the LEDs are constructed. So this is inside initialize. This is a code region for initializing all the components. And then after that is run, there's a connect stage where all the component connections have their code emitted. So we can see here when a push button is clicked, it fires a value changed event, and the value changed event is emitting code to set the LED one's is on value to the new is click value. So all of this code actually comes from the definition of the port itself. So there's a Boolean driver and a Boolean receiver port definition that take some information about what the component's name is and what the port's name is for both sides, and then it provides the code to connect these two. And so that's pretty cool. You can follow along directly and see what design is being done on your behalf when you're dragging and dropping components. And then for the target, we've called this a target model builder. So we drag and drop this target, and the way that we build out, the way this target is hosted in this environment is with the target model builder. And this literally is building a model of the target. So let me update this change. We just drag and dropped a new target, so there's now a new full target model class that's inside Virtuoso Core. So Virtuoso Core is the view model files that are managed by Virtuoso. So Virtuoso is managing this target model C# file, which is the C# model of the executing target. So the framework is doing a lot in the background to give you this C# class that you can interface at the host language level to interact with your executing target. So you can actually get the power output. You can this is a property getter that is a Boolean property interface, so you can set the value on this power output to power the virtual microcontroller on and off. So when you set that false, the microcontroller code closes and this whole target gets disposed. And when you set it to true, this whole project actually gets spun up and executed again. So in your virtual environment, you can actually be turning different microcontrollers on and off. So when we go in and create a variable, sim LED output, we compile our project. And then we add it to the target model. So we do our quick configuration. So we have our new port, and this port is interfaced in the code by this property that's now been added. We need to push the changes here. Okay, so there's our sim LED output. So now this model has a Boolean property sim LED output that's been added to it. And what's important to understand is that you can think of this as just a normal C# class. There's absolutely nothing different about this class in C# as any other class. And the framework in the background is doing a lot to keep this target synchronized with the actual C project, but you don't have to worry about that. You can just think of it as if you're wanting to interface to the target model in C#, it's just a normal C# class. And the target model builder helps you build that out. So you can always, in your host view model code, you can go in here and reference this target model and write C# code to interact with it. So you can stimulate it, you can drive it with inputs, read outputs, and drive your SPI, I2C traffic, all that stuff in code if you want to. So on the base host view model properties, we have now this target instance. This is what I named it, target. So in my host view model, I can reference that target directly and say my power sim LED output is the output, and the value is the value of that at any time. If I add this, you can see it's reading that output of the target. So if this was an input to the target, you could drive that value. So again, the whole rationale behind this architecture is to be able to use low code to quickly build out your functionality and then directly do whatever you need to, and the optimum host environment for designing low latency desktop applications that run on your computer. So the microbus has the same concept. When you drag and drop a microbus board, the code that's emitted is a C# class that represents this whole board, and this includes a property that is this microbus slot. This microbus slot has all of the C# equivalent behaviors of a single clipboard interface, the microbus interface. So after we drag and drop that, we can go and see there is our microbus board view model. So you can go in and kind of peek out what's on this. You can see there's the LED 6, LED 54221. These are the Boolean properties for the LEDs. These are the microbus slots. And so you can just see real easily how a component is implemented in C# and how you can interact with it. So again, this is the architecture is so that you can completely do whatever you want, either hardware in the loop, you can access the interfacing to the peripherals directly as if they're just normal C# classes. And then theoretically, what else can you do with that? Well, there's a lot you can do with that. This is an example of something else that we have, a C#.NET container for Unreal Engine, so you can actually run Unreal Engine inside a .NET application. And so if you're not familiar with Unreal Engine, it's a video game engine by Epic Games that lets you design video games with all of the rendering power of the modern game engine. So I just run this, and you can see that this is a desktop application just like our host, right? So this is no different than the host that we just created. It's a C# WPF desktop application. And it has Unreal Engine embedded inside it, and this entire Unreal Engine world is proxied as a C# class. So it has properties for this lamp actor. So this is a normal C# view for a logical lamp. So there would be one view model for this lamp as a C# class, and this view binds to that lamp view model, just like this 3D lamp inside Unreal Engine binds to that same exact view model. So if you have that view model with red, you have let's say you have a Z-axis value, and you have red, intensity, turn the intensity up, red, green, and blue. You can control these as just normal Devil Precision properties. And now you are able to interface to an Unreal Engine environment and get values in and out of the world. And in low code, if this world is available in low code, so you have Unreal Engine component that's proxying and providing a low code interface to the world, and then you have the lamp actor, then now you can just wire up so that your output from your virtual target drives the color of the lamp or the intensity of the lamp. And then you run your environment, and you're actually able to navigate around in the world, and it's executing your embedded software. And the embedded software is reaching out and controlling and interacting with the Unreal Engine virtual environment. So as you can see, lots of potential with the platform. There's really no limit, and the way that it's architected to be able to support absolutely any use case and deliver as much power as possible.